When we talk about having storage in our computer, there's another topic that we have to cover called RAID systems. RAID stands for Redundant Array of Independent Disks. And RAID actually allows us to have either faster read or write speeds or extra security in our data. It really depends on which type of RAID that we use. And there's several different types of RAIDs, and there's different combinations of RAID types that you can use. But the RAID types that we're going to cover today are going to be RAID 0, RAID 1, RAID 10, and RAID 5. Now, RAID 10 is actually a combination of RAID 0 and RAID 1, but we refer to it as RAID 10 just because it makes it a bit easier than saying RAID 0 plus 1. When we talk about RAID 0, the key term that we want to remember is striping. Now, when we talk about striping, what we mean is we actually have at least two hard drives. We have at least two drives that we can write to at the same time, or when we can write to as we're performing functions on our computer. If we have two drives that are written in RAID 0, and we're trying to save information very quickly, it allows us to speed up that information because if we're, say, writing some information here one block at a time, we can simultaneously be writing stripes of data on this one. This striping increases the speed which we can write because these two independent disks can be reading and writing at the same time, and we don't have to spend as much time going around the disk in order to find or write the data. The downside to this setup, however, is with RAID 0, there's no backup. So if one of these drives fails, we can no longer get information just from this drive. This is incomplete information. Say that Word document that we were saved in chunks. So let's say it saved in, it was a 123 kilobyte file. Well, we may have 36 of those kilobytes, say, striped onto this drive, and then the rest of the information was actually saved on this drive. So just because we have one functioning good drive doesn't mean we have the rest of the Word document, because the rest of that data was on the drive that failed. So while it's good for helping us speed up information reading and writing, it's not good if we want to have that data backed up. So we have a different solution for having data that is more stable, and this is called RAID 1. And the key word to remember with RAID 1 is mirroring. Now, with RAID 1, with mirroring, we still need at least two drives. But instead of striping the information simultaneously on each drive, these drives are actually going to be mirrors of each other. So when we're writing our Word document on this drive, it's actually going to be writing the same information on the other drive. That way, if one drive fails, we still have the exact same information on the secondary drive. This helps us if we want to have good backups, or if we're in a situation where we need to have that data if one drive fails, and we want to be able to constantly have good uptime. So say if we're in the middle of production, we're in the middle of people accessing files on a server, we don't want one down drive to stop everybody from being able to access that data. So this secondary drive is still able to read and write the data. Now, it's not any faster than just having one drive, but it is more redundancy. So striping provides speed only, and mirroring, RAID 1, provides redundancy. When we talk about RAID 10, we have at least 4 drives, and this is going to be striping and mirroring. And remember, this means RAID 0 plus 1. With RAID 10, we have at least 4 drives. With each of these drives, they work in pairs. We'll say these 2 drives over here are one pair, and the drives on the right side are their own pair. While we're writing data on the drives, it provides for quicker read-write, and it provides for redundancy. Because while it's writing data, on the left drives, it's striping, so it's writing it as quickly as it can. But whereas in our previous instance, where if one of these drives failed, we wouldn't have any backup because the data is split up between the 2 drives, in this case, these 2 drives are mirrored exactly onto these 2 drives, with drive A and drive C being mirrors, and drive B and drive D being mirrors. A and B stripe together, but A and C mirror together. So it provides us with speed and redundancy. If A fails, then we still have C and D are completely up and running. That information that was on A is now still on C, so we're safe. We would definitely want to make sure that we get a good drive up taking A's place as soon as possible, but while we do that, we still have the uptime just with B, C, and D. They're all still working. Our last RAID type is going to be RAID 5. The key word we want to remember is going to be parity. With RAID 5, we actually need at least 3 drives, and we'll call these drives A, B, and C. We actually have striping going on all of these drives. So as we're reading information, as we're writing information onto the drives, wherever our drive head is, wherever we can write the data the fastest, it's going to do that. So it's going to start writing our Word document on A and start writing information on B and start writing information on C as well. And all of these may be different bits of information. What's different about RAID 5, however, is we have something called a parity bit. Now, the parity allows us to have recovery information on a separate drive than where the data is located. Let's say that drive A writes information that we're going to call A1, and then drive B has information called B1. Then our parity on drive C, we may have parity for A1 and B1. Now, that information can't just be accessed like the standard information blocks can, but that parity allows us to be able to recover that information. Say if drive B fails, then by using drive A and drive C, we can recover that information. Now, not all of the parity information may be on drive C, not all of the parity information may be on drive A. It just depends on where the RAID system decided to write that information, where it decided to write the parity. But by using these two together, the RAID system will store that parity on a drive that's not the drive where the information is stored. So we can actually recover that information if need be, but it may take some time. So we have a bit of redundancy, but we also have that speed with the striping. Just to remember, with RAID 0, we have our striping, but no redundancy. So we have speed, but if something fails, then we don't have that anymore. With RAID 1, we have mirroring, so we have our redundancy, but we don't have speed because it's those two drives and they're only mirroring each other. RAID 10, RAID 0 plus 1, we have striping with mirroring. That striped information is then mirrored onto separate drives. So with RAID 0 and 1, we only need 2 drives minimum. With RAID 10, we need 4 drives minimum. And then finally with RAID 5, we have striping with parity. So we have the striping all across the drives, but we also have the parity information in case one of the drive fails and we need to recover it. This requires, again, at least 3 drives. So there's a few different types of RAID. There's more than there are listed here, but these are the basic types of RAID that are good to know. When we're doing a RAID system, when we're setting it up, it's best to have identical drives as much as possible because we definitely want the write speeds to be the same. We want the rotations per minute to be the same on the drives. So it's best to have the exact same identical type of drives. We want to make sure that our motherboard and our BIOS actually also support RAID as well. This would be called our hardware RAID. Not all systems can support RAID, so we want to make sure that before we set it up that our motherboard does. And then lastly, we can create software RAID systems, but they're not as robust as a hardware RAID system where our motherboard and our BIOS actually support RAID. So we want to make sure that we do our research on our particular types of motherboard and our particular systems before we just jump headfirst into trying to use our existing systems to set up a RAID system.